Hey everyone, welcome back to this master series on learning coding patterns. My name is Muhammad Ali and today we are going to solve question number 503, next creator element approach 2. Okay, before solving this question, I would like to first of all thank Hari for mentioning monotonic stack approach. So basically I used to think like these next creator element, next smaller element, previous creator element, previous smaller element, these type of questions are like different, are following different approaches on their own. But Hari mentioned monotonic stack approach, and now after reading it and understanding it, basically these questions fall under the umbrella of monotonic stack. And what is monotonic stack? So very simply speaking, monotonic stack is just like a normal stack, but here the progression of increment or decrement in a stack basically occurs monotonically. And what this monotonically means, I mean, you have to read a little bit about it, but just for a icing on the cake, very briefly, basically there are two approaches here: increasing or increment in a stack or decreasing a stack. And in increasing stack part, you can understand it just like a function. So for example, y equals to fx. Okay, so if x will increase, y will also increase. So there is a direct relationship here, okay, in the increasing stack part of monotonic stack. In the decreasing stack part, let's say if x will decrease, so y will increase. So this is an inverse relationship here. Okay, so I would encourage you to read more about it. Hopefully it will help you understand what this approach is and what this approach consists upon and how it works. Right now let's jump towards this question, and maybe understanding this question will help you like how monotonic stack works. So here we are going to solve next creator element part. So how we are going to solve it? Basically, the next created number of x in an array is the first number larger than x encountered while circularly traversing the array. So this time we have found, like, rather than a normal array, we have found a circular array. Now the question Ali arises, what is a circular array? So a circular array is something, okay, let's say we went from 0 to last element, and then the very next element of last element is going to be the first one. Okay, so this is how it is going to work. Okay, so first let's say from 1 to 3 we will traverse, and then right after 3 what we will encounter, we are going to encounter the very first element, and from there on we will again traverse to the very end. Okay, so this is how circular array works. I hope now at least you will understand, okay, what circular array means here. Now what these two slashes means here is like this is the end of an original array. Okay, like for example, just to mention the n, so n here will be 5. Why 5? N means length. Okay, so 0 1 2 3 4. Okay, so 1 2 3 4 5. So these are 5 elements, and that's why the length of original array is 5. But since we are dealing with circular arrays, so that's why we have like created this duplicate array after this one, just to give you an idea that after this 3 1 will come. Okay, and we are going to use this array as well in our traversal, but a little bit differently. You will find out, like, okay, how the things are going to work. Okay, so just stick with me. Now let's start our question. So how we are going to find the next creator element? First of all, we are going to start our current pointer from very beginning, from 1. Now we have this stack here variable, and this variable is basically a list, and this top is representing the very last element of our stack that is appended to our stack. Okay, and here we have this res, and res is basically a resulting array, and we have initialized this resulting array with dummy variables of -1. Okay, because our question states that if next greater element exists of an element, then mention that element. If there is no greater element of that particular element, let's say x, so we have to write down -1 instead of it. Okay, so Now let's start our question with this current pointer, and our current pointer will start from the very first element. So let me first write down the indices. So 0 1 2 3 4, okay, and then 5 6 7 8 and 9. Cool. So current will start from 0 index. We will first check whether our stack is empty or not. Right now it's empty, so what we will do, we will check whether our current pointer is at an index that is smaller than n. Yes, 0 is smaller than 5. So what we will do, we are going to append this 0 to our stack, and 0 will be our top, okay, top of our stack. So now what we will do, we are simply going to move this current pointer to the next one. Now again we are going to check whether our stack is empty or not. No, this time our stack is not empty. So what we will do, we will check whether the value at top of our stack, okay, in nums, like here we have 0. So at 0th index in nums there is 1, and this 1 is smaller than the value at current index. Yes, 1 is smaller than 2. So what we will do, we will come here. Remember this 0, right? So we are going to pop this 0 from our stack, and then we are going to use this 0 at the 0 1 2. Let's say I'm just writing down the indices here. So at the 0th index of res, from popping from our stack, we are going to update our res at 0th index. Now what value we are going to update our res with the value at current pointer. Right now our current pointer is pointing towards 2, so just come here and remove this -1 and write down 2 here. Cool. Now again we are going to check whether the current pointer index is smaller than n. If yes, which is yes, like 1 is smaller than 5. So what we will do, we are going to append this 1 here, okay. Remember, index will be appended here, okay, and this 1 will be at our top of our index, okay. Now we are going to move this current pointer to 3. Now again we are going to check whether stack is empty or not. No, stack is not empty. Then we will check whether the whether at nums we will the value at whatever the stack top of the stack is. Right now it is 1. So the value in nums at first index is greater or smaller than the value at current. If let's say here we have 2, so 2, if 2 is smaller than the value at current, which is 3, 2 is smaller than 3. So what we will do, again we will repeat what we did with 0. So we will come here, we will remove this 1, and then we will use this 1 to locate the value we need to change in res at first index, okay. Now we will remove this -1 and we will update our res with 3, the current pointer's value. So here 3. Now current will move to 4 again, but before moving to 4 I forgot, like here we have 2. 2 is again smaller than 5, right? So we will append 2 here. 2 will be a new top of stack. Now we are going to move our current pointer to 4. Now again at top of our stack we will first check whether our stack is empty or not. No, our stack is not empty, 2 is there. And then at top of our stack we will use this 2 to locate nums at 2. So we have 3. 3 is smaller than 4. So what we will do, we will again come here, we will pop this 2, and then we will use this 2 to locate the second index position in our res, and then we are going to update our res with whatever the value current is pointing towards, which is 4. Now again we have to update our stack, so we will check whether 3 is smaller or greater than 5. It is smaller than 5, so we will write down 3 here, okay. Now again we are going to move our current pointer forward, and here we have encountered 3. We will check whether our stack is empty or not. No, our stack is not empty. Then we will check whether the top of our stack which means like 3. So at third index of our nums there is 4. Now my question to you is whether 4 is smaller than 3 or not. No, it is not smaller than 3. So what we will do, we will not pop this 3, rather we will check whether whether the index of our current pointer, which is 4, is smaller than 5 or not. Yes, it is smaller than 5. So we will update our stack with 4, and now this top will be pointing towards this 4. Okay, so now what we will do, we are now going to move our current pointer to this 1 because it is a circular array. Now what will happen, again we will check whether a stack is empty or not. No, our stack is not empty. Then we will check whether the value at 4, okay, at 4th index, which is 3, is smaller than the value at current index. No, 3 is greater than 1. So what we will do, we will do nothing, and we will move our current pointer forward. Why not, Ali? We have updated stack because stack will only get updated up to the point of original length, which was at this point. Now again, for the case of 2, we will check whether stack is empty or not. No, stack is not empty. Then we will check whether the value at 4th index, which is 3, is smaller than 2. No, it is not smaller than 2. So what we will do, we will do nothing. Again move forward our current pointer. Now current is pointing towards 3. At top of our stack there is this 4th index, and at 4th index we have 3. 3 is not smaller than 3, it is equal. Okay, so we will do what? We will do nothing, and we will move forward. Now after moving forward, our current pointer has found 4, and at top of we will check whether our stack is empty or not. No, our stack is not empty, and at top of our stack we have this 3. Now 3 is less than 4. So what we will do, we are going to come here. Remember this 4, we are going to pop this 4, and then we will use this 4 to locate the value we need to change in our res. So at 4th index there is this -1. We will remove it, and by which value we are going to update it to the value that current pointer is pointing towards, which is 4. Right now current pointer is pointing towards 4. Okay, so new value in our res that will be updated is 4. Okay, now what we will do, since the current pointer is pointing towards an index that is greater than the length of our original array, so what we will do, we will not add any like index here in our stack. Rather we will just move our top to 3. Now again we will check whether our stack is empty or not. No, our stack is not empty. Then we will check whether the top of a stack, which is 3 at 3rd index, we have encountered 4, is smaller than the value at current index 4. No, it is not smaller. 4 is equal to 4. So what we will do, we will do nothing and move our current pointer forward. Now our current pointer has found 3. Okay, so we will check whether our stack is empty or not. No, our stack is not empty. And the next thing that we will find is that at top of a stack there is this 3. So at 3rd index we have found 4. So whether this 4 is smaller than 3 or not. No, this 4 is not smaller than 3. So what we will do, we will do nothing, and since there is no value after this 3, so our loop will break. So what is going to be the final result? This is going to be the final result: 2, 3, 4, -1 and 4. Awesome. I hope you at least by visualization you are starting to develop some sort of intuition, some sort of sense how the code will proceed and work. Okay, so now let's move towards the coding part. So here we are at question number 503. Next, create an element 2. The question difficulty level is medium, and this is the case 2 that we have just seen this example in our visualization. So let's jump towards the coding part. So we are going to start our coding part with n. N was, remember, n was the length of our array, right? So length of nums, here we have nums. Okay, so after length what we are going to define, we are going to define our stack. So our stack is going to be an empty one. Then we are going to define res. Res is going to be the dummy array with values -1. So the easiest way to create it is n into, let me give a space, so n into -1, this brackets, and inside inside brackets I have mentioned -1. So what will be the final result? Basically this is a list and the first value is -1. So when it will be multiplied with n, so n size of list will be created with values -1, okay, at each index. Then we are going to start our for loop. So for I in range, now n into 2. Ali, why this n into 2? Because remember, this is a circular array, so the length of our traversing array is going to be the double because of the circular part. Now here is the most intuitive part of this question. Num equals to nums I modulo and then n. What this will do, basically, this part will create what? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, let's say here in our case we have 5, so n into 2, since it is starting, so n into 2, 5 into 2 means 10. Since it is range, so it started from 0 and last element was removed, so 0 to 9. Now what this part will do, this part will help us, rather than occupying more space by creating duplicate one. What it will do, it will start from 0, 1, 2, 3, and then what will happen, after this it will go for 4, and then again it will start from, after 4 it will start from 0. So 0, 1, 2, 3, 4. Again if you count, so there are 10 elements, but thanks to this part, what will happen after 4, rather than we needed to create like a double sized array of this 1, 2, 3, 4, 3 and then again 1, 2, 3, 4, 3. What this will help us, this will help us traverse after this 3, again switching back to this 0 position, which is 1, and then the story will continue till the very end. Okay, please feel free to check to try it out on your own, play with it, try to understand how this code is working. If you still face any issue, feel free to comment down below. I will love to explain it to you in more detail, in more depth. Okay, so now let's move forward. So here let's define our while part. So while stack, remember the condition whether stack is empty or not, and then we checked nums stack -1. This stack bracket -1 means top of our stack, and then we use that top in order to go into nums and then check whether the top value is smaller than num, smaller than the current value. If it is, then what we needed to do, first of all, we popped from our stack, and then we use that pop to locate what? To locate the position where we needed to change value at res. And then what value we updated our res with the current one, num. Okay, afterwards we defined I is less than n. So why this I less than n? Remember that part, original length of array. So we updated our stack only to the point where I was less than the length of our array. So stack dot append and I. Cool. Finally we will return res, because res is going to be our final array. Now click on run, and our initial test cases got accepted. Here we can see the same result as visualization. for 1 2 3 4 3 we got 2 3 4 minus 1 and 4. Okay, now let's click on submit, and voila, here we got all of our test cases got accepted, and this code is working fine. I hope like the visualization and code is understandable to you. If you still face any issue, please feel free to rewatch this video or comment down below this video and ask your query, your concern. I would love to help you out. If you like this video, if you like this effort, please feel free to support me by liking this video and sharing it with the people who are currently preparing for their technical interviews. Thank you so much for your time, and I'll see you with the next question in the new video. Take care. Bye. Peace.